Okay, welcome to the data warehouse session. So yesterday we have seen, so what is data warehouse? Why do we need this data warehouse? So what is the use of this data warehouse? What is data lake? And so how it will be differ from database to data warehouse and everything we have seen, how we are loading the data. So what is ETL? So where the Informatica will come into picture, everything we have seen. So do you have any doubt in that? If you have any questions, you can ask me now. I will answer the question. So are you clear?
Yeah, yes.
Okay, today I will tell you after this session, I will tell you how to install the software. So what are the different setup we have to make, and how to install Oracle, how to install Informatica server, how to set up, and how to start with everything. I will guide you. Okay, so don't worry on that. Okay, so now we will continue. Yesterday we have seen that we have two different approaches. One is top-down approach, another one is bottom-up approach in data warehouse. He is the person, a father of data warehousing. He has published a paper in international journal that, okay, we instead of having OLTP system, we can have OLAP system to have analysis on the data. So that's what he has published. After 10 years, Ralph Kimball has published another paper. So instead of going for top-down approach, we can go for bottom-up approach. These two methods are used in our real time. Who will take care? See, all these methods will be taken care by the data modeling team. So what is data modeling? What are the different tools are there? That I will explain in separate slide. Okay, the inbound model, as I have mentioned, this is our source system. So our heterogeneous source system, we will do ETL process, load the data into a data warehouse. See here, directly we are loading, but in our real time, it will be there multiple stages. Okay. Stage by stage data will be moved to the data warehouse. We'll be doing a lot of ETL logic, and then the data will be moved to data warehouse. So once the data has been moved into a data warehouse, then again it will be moved on the data mart. So data mart is nothing but subset of our data warehouse. Okay, how we have in our system, so 1 TB of hard disk, we are splitting the 1 TB into C drive, E drive, F drive, right? The logical division. The same way here also, we have the logical division of the data warehouse is called data mart. So in real-time project, if you are working for one particular data mart, so merchant data mart, customer data mart, supplier data mart, okay, different data mart will be there. If you are the Tableau developer or Power BI developer or any other developer, report developer, so definitely you'll be having this particular data mart alone access. Okay, you'll be having access to this particular data mart. So other data mart, if you need any access to this table, you have to get the approval from the customer. Okay, from the customer, and then you have to inform to the DBA. DBA will provide you the access. Okay, this is what in real time you will have access and privileges. Okay. So top-down approach. Bottom-up approach. First, we will load the data into data mart. Here also we can take from here. Here also we can take. Data can be, so you can take the data from this data mart, or consolidated data will be available in data warehouse. Here also we can take it for reporting. So anywhere you can take. So this is what the bottom-up approach. Okay. This is what the bottom-up approach. Okay. So I got one question. Are we splitting data into data warehouse based on the schema, or splitting as a disk spaced partition? Okay. So we are splitting the data into a data mart based on business. Okay. Based on business, not for the, not with any schema. Okay. So I told, right, it's a merchant data mart. So merchant related data will be loaded into the merchant data mart. Okay. Merchant related data into a merchant data mart. Then customer related, see you are working for customer reports, then customer related data will be moved to customer reports. Okay. So that we will explain. Okay, so that I will explain separately. Okay, so here what is HA cluster and the group listener in SQL? See, these are all DBA concept. HA is nothing but high availability. Okay, high availability cluster and group listener. The listener will be running in the backend. Okay, listener will be running in the backend in Oracle database. I will show you whenever you are installing the software, right? So first the edition will be running, the software will be running. In addition to that software, the listener will be running. Okay, so TNS listener, then different listener will be running. So that's what it will make the connection. It will make the connection in the backend. These are all like a DBA concept. So Oracle DBA or some other DBA concepts. So that I will show you once we have installed that listener and all, I will show you. So this is what the database we have, database and data warehouse. Okay, data mart, data warehouse. See, data mart is nothing but again, it's a subset of our data warehouse only. It's a logical division. It's a logical division. Okay, these are all the logical division. We have logically, it has been splitted, but it's a single physical hardware only. Okay. Okay, now we have, this is what next one is like we have data mart and data warehouse and top down bottom up approach. So what is the difference between top down and bottom up approach? We have Inman model, it's a top down approach. Kimball model, it's a bottom up approach. It's a more time consuming. Okay, if you to build the data warehouse, it will consume more time, and the maintenance is very easy. Maintenance and subsequent project development cost is lower, but initial cost is very higher. Okay, so first we have to build data warehouse, then we have to take the data mart. It's a longer startup time. Okay, it's for enterprise wide. It's for entire enterprise wide. We'll go for the data warehouse. So this is for the individual business area. So one business area we will go for, I told, right, one subject like merchant, customer, supplier, right? So all these are Kimball model. So it takes lesser time. You can create a data mart quickly and then you can take the data. But after that, it will take some low initial cost, but after that, the maintenance will be high. Okay, this is what the difference between the Inman model and Kimball model. Now we have both model. Okay, so hybrid model. So from source, do the ETL, load it into a data mart. So from the data mart, it will be loaded into the data warehouse. Okay, then it will be moved to the data mart again data mart. So from here also you can take the data from the user. From here also you can take the data from the user. Okay, this is what it will be, hybrid approach. So who will do all this in real time? So we are, as a ETL developer, we are not going to do. Data modeling team, they will do it. Okay, data modeling team, some separate teams will be there. Okay, so we do have two different tables in Informatica. That's what data warehouse. So this table is very, very important. So whenever you are going for enterprise data warehouse, so definitely you are looking for only two types of table. Either it should be a dimension table or it should be a fact table. Okay, so what is dimension fact table? If you go to the data warehouse, right? Data warehouse, I want to build a report. So how we will load the data? Say for an example, if I have employees data, I will load all my employees data in the employees table. Okay, all my customers data loaded into the customer table, customer data. So all the customer ID and customers data, employee ID, employee data, product information, and location information. See, all this information will be loaded into a different tables. So these are all date table, okay, location, store table, different store. So why we are loading all the data into a different table, right? At the end of the day, I want to know what is the store wise sales, what is the product wise sales, what is the customer wise sales, regional wise, country wise, right? Different dimensions. I want to analyze the data. Then I'm loading all the dimension into different tables. Then I will be having a fact table. You'll be having a centralized fact table here. It will have all the transactional data. Okay, whenever we are doing the business, See, first we are capturing, okay, this customer purchased this particular product, okay, on this particular date, okay, from this particular employee, from this particular store, particular region, particular country, see all this particular store, everything I will capture. So these many product he has purchased, one product cost is this much and total price is this much. So each and every transaction will have the data. So this data we will call it as fact table. This is the fact table. Okay, it's the centralized fact table. Fact table will have the transactional data. So always fact table will have transactional data. All the keys from this table will be connected. The key values from this table. So this is foreign key primary key relationship. So you can watch my SQL session. So today I will tell you how to install the software and how to practice our SQL. That I will tell you. So please start working on it. And one session I will take it on SQL. Okay, so that you will get an idea how to start with SQL. Okay, so this is the fact table. This is the dimension table. So all these are dimension table. Dimension table will have always a primary key. Okay, remember, dimension table will have a primary key and fact table will have a foreign key. Okay, fact FF. You remember, fact table will have a foreign key. So what is the foreign key? These are all the foreign key. Then measurable values. These are all the measurable values, right? So measures will be having it. Non-measurable attributes and primary key. So what is primary key? So I will tell you now. So this is the data model we will create. So who will load this table? As a ETL developer, we have to load it. Okay, as a ETL developer, we have to load it. So how to do it? So I will tell you how these tables are related. If you look at here, whenever we are doing the transactions in our real time, okay, whenever we do the transaction in our real time, if you look at here, I want to start the business. I want to start a company so that I will have all the reports. So how we will have the reports in our real time, right? So I will load all the product related table in the product related details in the product table. So each and every product which is available in my company will have a product ID, separate product ID. Okay, each and every product will have separate product ID, product descriptions, all the related to product description. This is called primary key. This is called different dimensions. Okay, attributes of the particular dimension table. If you look at here, dimension table will have a primary key and attributes. The primary key here, it will not accept any duplicate value. I cannot give for this any other product, I cannot give the same number. Okay, without primary key, without this key, I will not have the product name and everything. So primary key should be there. So separate key should be there. If you are going for any company, you'll be having a separate employee key, right? Employee ID. The same way, each and every product will have the product ID. Each and every customer will have the customer ID. Okay. So every customer has been loaded into the table. We'll have the primary key. The same way, employees table, accounts table, all this table will have it. Okay. I will have all the tables. The store table, locations table. This is what the dimension table. See, whatever the dimension needed for our data model, I will load all the dimension table. So from where this dimension table will be loaded? From source only. From OLTP to OLAP we will load. But while loading the OLAP, we will maintain the history. That I will tell you how to do it. But we will get the data from OLTP only. Okay, OLTP also they will maintain. That is what ER model, entity relationship model, we will use in our OLTP system. Okay. So now we have the fact table. So if you are going for a particular store, right, you are doing any business, like you are purchasing a particular product, then you are giving that product to the particular person, in employee. So they will be maintaining that, they will be reading the barcode of the particular product, and then all these details will be captured. So what are the details? When you are purchasing, what is the date? Okay, which product you are purchasing? What is your customer ID? They will take your customer ID card, okay, or the number, mobile number. Which employee is helping you to purchase the product, okay, and store ID, which store you are purchasing a product, which regions. So all this will be captured in this fact table, sales table. See, these are all foreign key. So why I am capturing? So whenever I'm going for the transaction, I will capture that. And quantity. So how many quantity? So 2 quantity has purchased, unit price and the total price. Okay. So 1 unit price is 3,500, 2 unit price 7,000. All this will be captured. For an example, your customer is saying that, okay, at the end of the day, how much we have today's sales. So what will you do? You will go for sum of total price, date key equal to today's system date you will take. And I want to know in today's date, how much is the sales for each store. So group, so here we have to make date key equal to today's date and group by store ID. We have to make the sum of total price. This is what we will maintain in our reports. Okay, this is what we will take, but I do not know which store, right? So 7667, which is a store. Then I have to join this table. This store ID, fact sales store ID to dimension table store ID. I will join it. I will get, okay. So Mumbai Kalyan store. This is what? So Kalyan region store. We have the sales. So highest sales. So that I will take it from here. But I have to make the summation. So which product is, which store is, which region is. So everything. So this is what in our environment, it will be in our real-time environment, we will be keeping that fact table and dimension table. Okay, so is there any doubt? So this is the main table we will use in our real time. So if you have any doubt, please ask me.
Okay, Chandra, okay, you said right this fact dimension product dim customer. This at all OLTP tables, right?
No, OLAP is table. Yeah, this is the data is coming from OLTP only. Okay, OLTP only. The summation and all we will do it in the OLAP. Summation. In addition to that, we will do a lot of summations. So that we will do it in our OLAP side. Fact table, dimension table. This fact and dimension maintained in OLAP side.
Okay.
Normal table, customer table, product table, store table. Okay, that table will be maintained in OLTP. Say for an example, in OLTP, if you are changing your mobile number, it will be changed automatically. Okay, we will update it.
Okay.
For an example, this mobile number, we will update it like this in OLTP side, source side.
Okay.
But in OLAP side, we will not update like this. See, we will keep this particular record for here. We will keep this particular previous record for history. Okay, this record.
Okay.
So is it possible to maintain primary key, two primary key here if I am maintaining here? No. So I will be making one more key as something like a surrogate key. This is called a surrogate key. I will explain this concept later.
Okay.
But this is what we will maintain. We will make this particular data as inactive record. Okay, we will make this as inactive record. This is active record. So this is called slowly changing dimension.
Okay. The SCD types. Okay.
Yes, SCD types. Yeah. Dimension table, if it is changing, how we are handling it in our data warehouse. Okay. So data warehouse, we will keep it for history, but in our OLTP, we will not keep it for history. All your address, phone number, not only this particular table, all the table will be maintained for history in OLAP side, not in OLTP side. So OLTP side only the transactional data. Okay.
Okay.
And fact table contains duplicates, right? Like duplicates in the sense
duplicate will not be allowed. See, the fact table is the product ID will have duplicate, customer ID will have duplicate, employee ID will have duplicate, store ID will have duplicate. Okay, but this data normally a separate data only. This is unique data only. Why? Because the date key we are capturing, right? So you are going to purchase a product in this particular date and time. So it will be unique date and time only.
Yeah.
Unique date and time and unique product. Okay, this product might be, so some other person also purchasing the same product. That's not an issue. So it will have a duplicate, but this record is unique record. Okay. Transactional level, we will keep it. Transaction ID, so order ID, sales ID, everything we will keep it here. Okay. So the same product, multiple person can purchase, right?
Yes.
So this will have a foreign key will accept duplicate, but primary key will not accept duplicate here. This is what the main table in your data warehouse environment. The transaction tables are very main table. Always this transaction tables in our real time, right? Mostly it will be partitioned based on the date. So each day we will be having a partition, separate partition will be there. Why? Because it's a very huge table. In terms of TB, it will be available.
Okay.
Okay, that's what we will maintain all the partitions and everything. Okay, but understand how the fact and the dimension table will be connected with each other.
Okay.
Clear, right?
Yes, clear.
Okay, I will show you some practically. I will show you how the tables are real time, so that you will get an idea. But this is what the fact table, dimension table. Okay, how these tables are related? Like a star schema, snowflake schema. The schema, the star schema is nothing but the star schema is nothing but like we have like a star. This is the fact table. So you'll be having a centralized fact table. This is a sales table. You assume that this is a sales table. This is the dimension table. If you look at here, this is a dimension table. We have the city table. So city ID, city description, all other remaining columns also will be there. Employee table, country table, products table. See, all these 4 tables are dimension table. This is the fact table. This is the fact table. So in this particular country, this particular city, this particular employee purchased this particular product. So 2 quantity he has purchased, 1 quantity, sorry, 1 unit price is $200. Okay, so he has purchased 2 quantity and $400. That's what it will be maintained. So from source only we are taking the data. From source only we are taking the data, but we will maintain in the fact table in our OLAP side. Okay. See, if in fact table, the outer tables are dimension table. The dimension tables are connected with centralized fact table to get a meaningful report. To get a meaningful report. This is what the star schema. Okay. Now we have the snowflake schema. See, in the star schema, which table we have to load first? Can anyone tell? Which table we have to load first?
Dimension table only.
So why dimension table should be loaded?
See, dimension
This is
table,
source.
this is source, right? I mean, actually, the fact table is associated with the dimension table. So that is the
Correct.
reason.
It should be a primary key table. Okay, it should be a primary key table, right? So primary key table should be loaded first. So it's a master table, reference table. Okay, always we will maintain all the primary key. But remember, this dimension table will not change frequently. Okay. So do I need to load all the country data every now and then? No, right? So one time the country data will be loaded. So always the country data is same. If you are going to operate new business in new country, that time I will maintain one more country ID, right?
Yeah.
So otherwise we will be having the same country. This dimension table will not change frequently. That's what it's a slowly changing dimension. Okay, slowly changing dimension. Product table also. So product table, so we will have new products, but very slowly it will be changing. But fact table is having huge volume of data. Okay.
Chandra, I'm just having only one question, Chandra, here. Sorry, maybe it is out of box question. I don't know. This unit price quantity total at all, we need to create it, right? In the table, in the fact table, we need to create that, right? Even the dimension table, it is not the city ID, which is a primary key city, because the table construction which we will have in the dimension, but in the fact we need to create by own. This
Yes, correct.
how this unit price
no,
quantity and total.
Yeah, that's what we are not going to create it. So this data is coming from source. See, source you are capturing. See, one product you are purchasing, right? So while purchasing the product, they will be maintaining in OLTP.
Yeah.
See, in OLTP, whenever you are, then only I can know that, right? See, how many product you have purchased, I do not know. How do I know? Correct. In OLAP side? Okay, that will be maintained in our OLTP.
Okay.
From OLTP, while loading it into a OLAP, I will be maintaining in a separate dimension modeling. Okay. Like this, I will be maintaining it. In addition to this, I will be maintaining some aggregate value also. Okay. In addition to this, I will be maintaining some other value also. Okay. So that data model from OLTP to OLAP we will load. These are all OLTP. From OLTP, we will have all this data, 2 quantity, unit price for this particular transaction ID. Okay. You'll be having one transaction ID, and then you will be maintaining it all this.
Okay, thanks.
But I do not, I may not know, right? So for an example, if I have only fact table, I may not know which product is having highest sales. Can I give the product number to the customer? No. For the customer, it always should be a product name, right?
Correct.
So I have to join the table with the product table. I have to get the reports in Tableau or Power BI.
Yeah.
So that's what we will do in our real-time project. Okay.
Sure. Yeah.
Okay, this is star schema. In star schema, we have to load dimension table first, then centralized fact table. Clear? So this is one of the interview question they will ask. So how the dimension modeling they are maintaining in your project. So which table you will load first? Okay, that's what we will ask. They will ask questions. Okay, so now we will have Snowflake schema. So Snowflake is different one. Snowflake technology is different. That is data lake I have yesterday I have explained. Snowflake schema is different. Okay, Snowflake schema is in data warehouse environment. In our data warehouse environment, Snowflake schema is nothing but, okay, the Snowflake schema, if you have, this is one dimension table, right? This is one dimension table. This one dimension table, we are splitting this dimension into multiple dimension table. Look at here, this dimension table, we are splitting into multiple dimension table. So instead of having all the data in the single dimension, single locations table, okay, we are having the data into the another table. Okay, store ID, store name, store territory information. Before that, we have handled here. Okay, after that, we have moved this data to another table. Okay, we will maintain the store territory details in another table called territory. Whenever needed, whenever store territory needed, I will have this ID, okay, with this ID, and then I will maintain this. I will take this report from where this particular store is located. Whenever needed, I will go for store name. Yes, I will go for store name with the store ID. Whenever I need the store territory, then I will join this table, I will get it. Okay. So this is a primary key table. This is a primary key table. That is a dimension table. This is also a dimension table. See, one dimension table refers another dimension table based on the normalization. This is called normalization. What is normalization? So normalization, why we are going for normalization? See, normalization, we are going for normalization to avoid the data redundancy. See, in real time, OL AP tables are denormalized. Okay, denormalized. In entity relationship model in OLTP side, OLTP side is a normalized table. OL AP side, it's a denormalized one. Okay, our data warehouse is denormalized. So denormalized is nothing but this is what a denormalized. But here, Snowflake, again, we will normalize it. So what is normalization? To avoid the data duplicate, data redundancy, repeatness, we are going for the normalization. Look at here. Say I'm keeping my employees details here. I have the employee ID. I have all this ID column, right? So I have the employee ID, first name, last name, everything I have here, right? So this one I have. So here I have the employee ID. Okay. So here I have first name, last name, all this I have. So I have these details are from office address, billing address, POC, and everything is nothing but our office location. So you have 3 different office location. You assume that you have the 3 different office location. You have 1 lakh employees. Okay. If you are keeping your employee details and office details in a single table, what will happen? So every time you are repeating the same addresses, office address, 3 office addresses to all the employees, correct? If you have 1 lakh employees, the 3 office addresses are repeating for 1 lakh times here. Instead, what we are thinking, so maintain this office address separately. Okay, maintain this office address separately like this. Only 3 office address, right? 3 different office addresses, 3 different times you will make. So in office address table, address ID will be the primary key. Okay, in employee table, employee ID is the primary key. So this should be a foreign key. Okay, this employee located in office number 2, 3, 1, like this you can have it, right? Like this you can have it. So how many times I'm maintaining now? Only 3 times. So this is what I can reduce the data redundancy. Clear? This is what I can reduce the data redundancy. So this is called one dimension table. I'm splitting that dimension table into multiple tables. This is called normalization. First normal, second normal, third normal, right? So this is their normal form. This is what we are maintaining. So why? To avoid the data redundancy, right? So this is what we'll go for the data redundancy and everything. Clear on this? Any doubt? How it will be maintained? Normalization. See, one dimension table splitting the dimension table into another dimension table. So here, if you look at here you will be having the primary key. Here store ID will be a primary key, right? Store ID will be a primary key, and same dimension table will have a foreign key. If the dimension table is there in foreign key in our real time, that's there in the snowflake schema. Okay, here it is a primary key. Here it is a primary key. So what is primary key, foreign key? So that you have to learn from Oracle only, from SQL only. Okay. So try to understand if you are very new to this primary key, foreign key relationship and all. So I will explain how to learn this SQL. Yeah, please go ahead.
Sorry, I mean, you mean to say in the snowflake schema in the dimension table also we have two keys, primary key and foreign?
Yes, correct. See here, I will show you one real-time data model. Okay. So that you will get a clear idea.
Okay.
This is enterprise data warehouse real-time data model. If you look at here, so this is different servers, North America, Europe regions. We are getting the data from all these data sources through Informatica. We are loading into enterprise data warehouse, EDW. Look at here. Here we have the EDW, right? Enterprise data warehouse. So from the enterprise data warehouse, data will be pulled for reporting, business object. That time we were using the business object. And here we have the replication server. Replication is nothing but through Informatica only we are replicating. Just we are loading one-to-one load. After loading the data into a EDW tables, we are maintaining only, we are taking only Europe region data to Europe server. Okay. So to avoid the data latency in the network, we are maintaining the server in the Europe regions. There we are replicating the data. This is also ETL process only. We will take only Europe region data, loading into a EDW server here for the Europe regions, and from there it will be taken. So why? Because if the Europe region people, they want to take the reports, if it is going to the North America regions and then taking that, it will be on the network latency. That's why we are keeping the server here. We are doing the replication. For this replication also, we will be running the backend. We will be running the ETL process only. Okay, ETL process only. If you go here, I'll show you. So this is the one of the data model for finance domain. Okay, finance domain. If you look at here, you can able to see here. So this is the fact table, centralized fact table. You see here F underscore some fact table is there. Okay, these are all the dimension table. D underscore table. See these many columns will be there in real time. Okay, these many columns. Some tables will have less columns. Some tables will have very big columns. This is in snowflake schema. Why? So one dimension table is referring another dimension table. These two. Okay, these two are dimension table only. Okay, so data redundancy, to avoid the data redundancy, we are going for snowflake. But here, whenever needed, I will join this table. I will get the details. Otherwise, I will not go for. Same way, headcount. If you look at here, headcount management, like only star schema. We are not maintaining any snowflake here. Only star schema. Okay. And here we have galaxy schema. It's nothing but galaxy schema is nothing but multiple fact tables are connected with multiple dimension table. Okay. Multiple fact tables are connected with multiple dimension table to maintain the some data. Okay, reports. That's what the galaxy schema. So you look at here, sales and all, it will be a galaxy schema only. Okay. This is what we'll be having the real-time data model. If you go to the real-time project, they will show you this data model, how this data model is looking. Okay.
Okay. So these things and all will be done by data modeling team only. So we are not going to
yes,
do
yes.
anything.
These things are data modeling team only. But after they did the model, we'll be adding some columns. We are removing some columns in the table, existing table. Informatica, we are loading the table. A load logic we are changing. That we will do.
Okay.
So very initial stage, they will do it. We will load the data. Okay, so this is what the Snowflake schema. Okay, so what is the two different data warehouse and data lake? Yesterday I have explained data warehouse is nothing but the structured data only will be handled and the data will be processed. Okay, processed data will be loaded into the data warehouse. In data lake, the other structured, semi-structured, unstructured data will be handled. Raw data will be loaded into the data lake. From there, it will be processed. Scheme, that's what schema and write. Schema and read. Raw data will be loaded. After that, we will read the data from that. Storage, here we will have commodity hardware, low cost storage. Here it is expensive. Cost is expensive. That's what we are moving towards on the data lake side. In data warehouse, mostly the business people will use it. Business analyst, okay, product owner, all the business people will use it. In data lake environment, all the AI and ML data scientists, they will use it. So if I want to use AI and ML concept here, so we will use it in data warehouse side. Okay, this is what the data warehouse and data lake side we will use it. Okay,
Like
if,
in real time. Oh, sorry. Okay, Karen.
yeah.
Like
Please
in
go
real
ahead.
time, so I mean, I'm now supposed to going to data warehouse to data lake concepts, right? Because of cost issue. So, but this is also will be long process, right? Again, they need to do migration something on or.
Yeah, migration they will do. Yes, definitely.
Okay.
See, all the data we will not to maintain into a data lake. So we will maintain in data warehouse also. So we are also already in our project, real-time project. We are moving on to last year itself. We moved into a BigQuery GCP. Okay.
Okay.
So we were doing all the migrations. See, whatever the data needed for data lake, data scientist. Okay, for their reports, for their data analysis, everything. We were moving all the tables into a BigQuery. It's a migration. They are doing it. So once it has been migrated, as a ETL developer, we have to load. Okay, we have to load instead of Teradata, we'll be loading into a BigQuery. That's all.
Okay.
Hereafter.
So what is the understanding about the agile?
So agile is nothing but, yeah, this is what the agile is nothing but. So less agile, fixed configuration, highly agile, configure and reconfigure as needed, right? See, agility is nothing but you are splitting that entire work into a small work. Okay, small work, and then you are doing parallelly. You are doing parallelly. Okay, so all the work you are doing parallelly. So agility in the data warehousing environment, you can do very less. Okay, but here in data lake environment, we can go for high agility. So agile process we have, right? So we will be loading the data, and there is no need of testing. Very less testing is enough, and there is no failover. There is no support team, much needed support team. There is no much support team in our agility and all. So we will develop the code, we will put it in the production server, and then it will be running. So if any production issues are happening, the developer itself will take care. It's again depends on the team only, but I'm telling. So agility is nothing but in most of the areas, we are implementing the agility in our data lake environment is easy. But in data warehouse environment is less agility only. Running a deployment in sequence, okay, splitting the modules into small modules, and then we are having a separate team, okay, that is possible in data lake environment. Okay, this is what agility. If you are going for real-time project, so definitely these data warehousing roles will be there. Okay, business users. So business users is nothing but your product owner, okay, your application owner, your business owner, or your business analyst, data analyst, somebody else who knows the business. They're going to give business use cases, the requirement to us. Okay. So their business users, they're telling that, okay, we need to create a report in this format, in this way. We need to have a report. The data is there in source. Okay. Do ETL pipeline, load the data into a data warehouse, and take the reports from there. That's what the business analyst will analyze it. they will give the information. Okay, these kind of reports I need. For this kind of report, so these tables should be loaded from the source. That's what they will tell you. So what the report writers will tell, okay, report writers will create a data model, that the data primary key, foreign key relationship and everything. They will say like, okay, if I want to create the report like this, I need to have the tables in data warehouse. Okay, I need to have the data in the data warehouse. These are all the data should be there. So report writers. Then our ETL developers, okay, I will take the data from source. I will take the data from source. I will load it into a data warehouse here based on the data model. The data model will be created by data modeling team. So if it is a new business, definitely data modeling team, they will suggest us, okay, go for this particular data model. You load it into this table. They will give us the data model. We are going to load it. Report writers, they will take the data from here to a report, and then they will be creating a report. DBA will maintain the database. Okay, database environment. Okay, here all this database, this OLTP, OLAP, everybody is taking. In addition to this, we'll be having a report admin, Tableau admin, Power BI admin, Informatica admin. Okay, everything admin will be there, and we'll be having a testing team also. Report testing, ETL testing team will be there. Okay, data modeler. So they will be using, you heard about this Erwin, right? Erwin data modeling tool. So this tool they will use, Erwin tool, for the data modeling. We do have some different data model. I will explain that. That's what they will use it. Okay, this is what the different roles. And if you go to this in real time, these are all the popular ETL tools are available in the real-time project. So you'll be having Informatica Power Center. So Informatica is a company name. Power Center is a ETL tool. Okay, Informatica is a company name. We have Informatica IDQ, Informatica Data Quality, MDM. Okay, Master Data Management, Informatica BDM, Big Data Management, Informatica IACS, Informatica Intelligent Cloud Services. So different tools are there. Power Exchange, Address Doctor, lot of tools are there. So by using this Informatica Power Center, we can do the ETL process. Same way, competitors of Informatica is nothing but all our remaining tools are competitors like IBM Data Stage and Microsoft SSIS, SQL Server Integration Service. So SAP BODS, Business Object Data Services, IBM Cognos Data Manager. Cognos is the reporting tool. Cognos Data Manager is the ETL tool. Oracle Data Integration is the ODA, it's the ETL tool. SAS Data Integration Studio, Oracle Warehouse Builder, Ab initio, Talent, Apache Nifi, Pentaho, Xplenty. So Xplenty is cloud-based ETL tool. See, these are all the ETL tool. If you know any one of the ETL tool, so learning other ETL tool is very easy. The same concept you will use. Even if you are going for cloud big data or any cloud data load, right? ETL pipeline, same pipeline only we will use. Instead of this database, we'll be having a data lake environment. That's all. The connection and everything will be different, but loading process is same. Okay. If you are approaching Oracle for the entire data process in your company, they will say go for Oracle as the OLTP. Okay, Oracle as the OLTP, Oracle warehouse, and then use ODA. Okay, Oracle Data Integrator, the ETL tool, and here use OBI. See, OBI is nothing but Oracle Business Intelligence. So this tool, you can use it for the reporting, that they will tell. If you are going for Microsoft SQL Server, they will use SQL Server's database and data warehouse. Use SSIS is the ETL tool, and then use Power BI as the reporting tool. Same way, IBM. So you can go for Intisa for data warehouse. Okay, IBM DB2 for source system. So then you'll be having a data stage for ETL. So they will say all the related to IBM product only. So that's what, see, the companies will choose which tool they need to go for. So out of all the tools, Informatica is leading ETL tool. It will handle huge volume of data, support and failover mechanism and everything will be very high here. Okay. fault tolerance, everything will be high. So the same way reporting tool, you have Tableau, you have Power BI, you have ClickView or ClickSense, Cognos, SAP BO, okay, business object, Zoom data, and Google Looker, we have SSRS, SQL Server reporting service, Oracle Business Intelligence, Spotfire, MicroStrategy, Quick Insight. See, all these are reporting tools. See, we need to know at least what are the different reporting tools are there. Why? Because if you are going for ETL developer environment, you will be working with these two teams only. Okay, you will be giving the data for Tableau team only. So if they are finding any discrepancy on the data, so they will be contacting the ETL team only. Okay, so this is what enterprise data teams will be there. Clear? Okay, so if you look at here, the data modeling, so I will tell you the data modeling. So I will show you the data model. If you look at here, so what is conceptual, logical, physical data model? Who will create this? So normally this will be maintained by data modeling team. Normally the Erwin tool they are maintaining, right? So first of all, how they will maintain? This is just give you an overall idea. I will give you an overall idea. So first they will go for conceptual data model. See, what is a conceptual data model? So they will take like a pen and paper, and then they will have, okay, in order to create a data model for the particular company, so I'll be going like this: product table, store table, sales table, time table. See all this, how it is related to a fact table here. See, includes the important entities. Entities is nothing but table. And the relationship, how we are relating with each other. No attribute is specified. Attribute means the column names. No primary key, foreign key is specified here. Okay, just the conceptual design model. They will maintain all the how many tables are needed for this data model. Okay, finance data model, and then sales data model. So different merchant data model. Something for that how many tables are needed, that we will maintain it first. Conceptual data model. Okay, it's very highly abstract and you can easily understand. So we will not have any software tool to create a conceptual model. Just a pen and paper is enough. Okay. And then we'll go for the logical model. In the logical model, if you look at here, all the tables, we will maintain the column names. Okay. In time, what all the columns should be maintained? In product table, what are the columns to be maintained? In sales table, what are the columns to be maintained? And what is the primary key, foreign key? So here store ID is the foreign key. From where it is coming? From here it is coming. Store ID is the primary key. Product ID is the foreign key. It's coming from this table. Date key. Then after that you are maintaining two columns. Okay. So normalization occurs at this level. Normalization means we can split this table into two tables also. Okay. So that's what your logical model. So we are maintaining a logical level. Then after that we'll go in for the physical data model. What is physical data model? See, after creating like this, we will maintain each and every column. We will maintain the length. See, what is the data type? What is the length? What is the all the models we will maintain. And then by using the Erwin tool, we will create the model, right? After that, no need to create by ourselves. Create table name, all this. So if you go to the Erwin model, if you are saying that create all the tables, it will create at one stretch in the backend. No need to create manually. See all the relationship, which table should be loaded first. Sorry, which table to be created first. Okay, that it will automatically created based on the primary key, foreign key relationship. We are not going to create. If you are creating, first of all, we have to create primary key tables, then only foreign key tables, right? If you are trying to create foreign key table first, we will get the error. Why? Because this is we are having this foreign key here, so that cannot be created. But Erwin tool will create automatically based on that. Clear? So data type and the data column name and everything is based on the database we'll be creating here. This is called physical data model. So who will do all this? By using the Erwin tool or Power Designer, the data model team will create it. Data modeling team. Okay. Just to give you an idea, I have explained this. data modeling team. Okay, tomorrow I will tell you what is this normalization process. We do have normalization on the OLAP cube and all. See, what is OLAP cube? Look at here. I will take the OLAP cube. See, OLAP we know already. This is also one of the interview questions they will ask. Okay, this one they will ask the OLAP cube. See, OLAP cube is nothing but multi-dimensional data. Okay, if you look at here, multi-dimensional data. So OLAP, what is nothing but based on the multi-dimensional data model. So enables a user to easily and selectively extract and view the data from different point of views. So decision making in the business process. Okay. See, it's nothing but cube is for our reference only. Okay. So this cube, we can see this in different view, right? So top view, side view, front view, all the view, right? The rear view and everything, bottom view, everything. So one cube we are seeing in different way. Okay, product, supplier, category, and everything. So look at here. See, we are going to have this table model in this particular cube. See, category, we are having the 3 categories. So this is one category, confections. Like this, we'll be having this categories, category dimension. Okay, beverages. So all this we are maintaining in the category dimension. Okay. If I want to analyze in this category of data, so from this dimension, you will analyze it. We'll go for one more dimensions. Okay, here. This is like confections. So this one, another dimension. This is another dimension. This data will be showing only for confection data. So now you can go for, see, this is one dimensions. Each and everything is each and every dimension in the cube. Okay. So now you can see this. This one we have seen, but now if you look at here, this is like time dimension. January, February, March, April. So this is category dimension. So each category we have 1, 2, 3. Same way here we have the time dimension. January, February, March, April, like this, right? Or Q wise. So Q wise everything will be there. The same way we'll be having a measures in stock, on order, sales amount, sales cost. These are all the measurable values that we are seeing in different dimensions. So if I'm showing one value here, this is for one category for one particular month for one particular sales amount, one particular measure, right? Multiple dimensions are related. So you can see data in multiple dimension way. This is called a dimensional modeling, OLAP cube. Okay. If you look at here, I'm showing this way. So this is the data. Say for an example, I want to know the January data. So what will you do? So I have to sum up all this, right? For January, February, I have to sum up all this. March, sum up. Okay. So here I want to go for one particular category. Then I have to go like this, one particular category. Okay. This is what I will be analyzing the data in different dimensions. Okay, the same way here, I have the book category, the product category, quarters, Q1, Q2, Q3, Q4, and territory. Okay, so we have different territory. So if you are showing some value, how it will be, like you'll be having the different operations, like 4 operations. These are all the questions they will be asking in interview. What is roll up, drill down, slice and dice, pivot operations, everything. Okay. So roll up is nothing but summarize the data. See, you have the Q1, Q2, Q3, and Q4. If I'm asking the year-wise data, you'll be summing up all the Q, right? That's what roll up. Drill down means you have the Q1 data. So Q1, I want to go for month-wise. So you are drilling down. Q into month, month into week, week into day. That's called drill down. Okay. Slice and dice. Instead of having all the dimensional data, we are taking one slice and dice from that. So pivot operation is converting rows into columns. If you look at here, roll up operation is nothing but you are summing up. Okay. We have the data like this. See, you have the data, product table, you have the PC, book, shoe, and clothes. All the data you are seeing only for Q1. Okay, Q1, this is what PC, and this is for one particular locations. This is for New Jersey, Los Angeles, and this is for Australia regions. Okay. These two are US, these two are Australia. So now we are summing up. See, this New Jersey and Los Angeles, we are summing up as 2000. Okay. This is called roll up. And this Perth and then Sydney, we are rolling up. Okay, for this one. See, 395, 605. That's 1,000. You're seeing here, right? So that's called Australia region data. So this is called roll up. So you can roll up here also. So Q1, Q2, Q3, Q4, you can roll up to a year level data, yearly sales. So roll up on location, roll up on time, roll up on category. So that we can do it. Are you clear what is roll up? So roll up is nothing but summing up. Drill down is nothing but, again, here we have the Q1, right? 605. That Q1 we are splitting into January, February, March. So 605. So everything will be maintained like a table level. So in the table level data, like on date level, they will be maintained. So we are splitting the table into monthly, quarterly, yearly, weekly, all this we will be taking. So if you are summing up this 150, 100 and 150, it will become 400. So where is that 400? So we used to have the 400 here, right? This 400 for clothes for Q1, 400. This is what we'll be having it. Okay, clear on this? What is drill down? Okay, slice is nothing but one dimension we are taking. So out of all this, right, we are taking only one. New Jersey, Los Angeles, Perth and Sydney, we are taking for PC and category only. We are not taking any dimension at all. So this and all we are not taking. Only one we are taking. Okay, 605. This and all, only one dimension we are taking. Okay, slice and dice. Dice means this is what dice, same like a dice we have, right? We are taking one particular dice here. Okay, Sydney and Perth for Q1, Q2. For these two categories, we are taking large cube into small cube. The pivot operations for summing up some values. Okay, we are going for the pivot operations. Like we are splitting the rows into columns into rows for different analysis. So this is what the different roll up and cube and all. So we have the OLAP is nothing but types of OLAP. See, we have the roll up, OLAP, and others. Okay, roll up is nothing but relational OLAP. Okay, RDBMS. Relational database management system, OLAP. That's what we have. Multi-dimensional OLAP. So normally it will be multi-dimensional OLAP only. Hybrid. See, other OLAP. So these are all something like data modeling team, they will take care. We are not going to do, but you have to understand what is this. They will ask. So do you know what is roll up? Something and all. Okay. So just you can tell them what is this. This is what the OLAP cube and everything. Clear? Okay. So now we have in our I will explain. I will give it to you. I will give you the software today. I will send it to you, the software link and everything. See how to build a setup. Okay, first you have to install Oracle 11G for the database. Okay, database as well as repository. I will tell you what is this repository. Repository will hold all the Informatica metadata. First you install Oracle 11G. On top of the Oracle 11G, we will go for Informatica installation. First we are installing Oracle 11G here. Install Oracle 11G. You split this into 3 different schema. So 3 different schema. Okay, 3 different schema. So one schema we are maintaining for metadata tables. One schema we are maintaining for source. One schema we are maintaining for target. So here in our environment, we are keeping this as source, this as target. So or if you have any other database, you want to install SQL Server, no issues. I will give you the software. Go and install SQL Server also. We will keep this SQL Server as target. So we will maintain Oracle HR schema as source and SQL Server is target. Oracle HR schema as source, core schema as target. See, anything is fine. Our source is Oracle, target is flat file. Okay, you will load the data into a file also, or you can get the data from a file, you can load it into the database. That's also fine by using everything by using Informatica. So first we have to install Oracle, then you have to configure the SQL developer. See what is your source, so what is the schema and everything you have to configure it. So configure SQL developer. SQL developer is the front-end tool. It is not a database. Okay, it is not a database. It's a front-end tool. You'll be having it, all the configuration. Third, you can install Informatica server 10.4 server. Okay, server, install it. You'll go for 10.4 now, and we'll go for Informatica client. Informatica client. So in 10.4 server itself, we'll be installing the repository service and integration service installation. So now they have given this server installation itself. Previously, we used to configure it separately, but now they have given. Once Informatica client has been installed, we have to configure the database connection. So we have to tell Informatica, okay, what is source, what is target. We have to create a database connection. After that, you have to go for the test mapping. Okay, test mapping. Clear? See how the Informatica we have to install. These 6 steps you have to follow. So I will give you today the software and keep it ready. Download it and keep it ready. And I will explain tomorrow the architecture of Informatica. That's very important. Informatica architecture and Informatica tool wise, I will explain. So what are the different tools are there? See how to configure the connections, database connections. So metadata, how it will be maintained, where it will be maintained. So what is the metadata tables, how it will be. So whatever we do in Informatica, how it will be maintained in the database table backend. So everything will be maintained, that I will tell you. Okay. So in this tool, we have the 4 client tools, right? I will explain all the 4 client tools with the architecture of Informatica. Okay. But now today and yesterday, we have seen only data warehousing concept. Please go through that data warehouse concept. What is OLTP, OLAP, what is data lake, what is ETL, just to go through that. Okay, one by one. You'll get an idea about clearly. So whenever you are going for interview, they will ask questions on this one. So today's assignment is types of fact table, types of dimension table. So look at types of dimension table. So please make a note of it. Types of dimension table, types of fact table. So just to go through that. What are the different types of dimension tables are there? Types of fact tables are there. Okay. So we have dimension tables like slowly changing dimension, rapidly changing dimension, conformed dimension, degenerated dimensions. Like this, we have some dimensions. Fact table, we have factless fact, semi-additive, additive fact. So 3 different fact tables are there. Just to go through that, what is it? Okay. If you have any questions, you can ask me tomorrow.
Okay.
Any doubt? Sir. So far, any doubt? All the data warehousing concept, are you clear? This is theoretical only. From tomorrow only, I'll be going for the practical way. Okay.
Okay, sir.
I will give you Informatica installation software and the link. So if possible, try to install it by yourself. I have explained everything clearly. Okay. If not, I will take your machine remotely. I will install it in your machine.
So the system needs any
okay, yeah, correct. The system requirement is, see, you need to have at least 6 GB of RAM. Okay, at least 6 GB of RAM. So for this version, if you do not have 6 GB, so go for lower version. Okay, 9.6 or 10.2, but it will be very slow only. 4 GB and all, it will be slow. You check whether you can able to extend if you do not have, but minimum is 6 GB, 8 GB, 10 GB, or sorry, 12 GB or and all. Okay, you'll go for minimum 6 GB required RAM, and then 50 GB of space. Okay, in the hard disk, at least C drive. So hard disk space you need to have. Okay, in the C drive where you are installing it. Okay, C drive you need to have, and then Windows. So you can have Windows 8 or 10 or 11, anything is fine. Okay, so this is the prerequisite for this one. And 64-bit OS. So definitely you should have the 64-bit OS. Okay. So if you have 32-bit OS, we cannot install it. So this is the system requirement for installation. I hope everyone is having it. So this should not be an issue. And if you have any antivirus for the installation, just disable the antivirus. After installing it, you can enable it. While enabling it, it will ask some exception. So add exceptions on the exe files. Sometimes it will remove the antivirus software, will remove it. But we have Windows Defender, right? No need to have any special antivirus software done. Windows Defender is enough.
Chandra, I already installed 10.2 Informatica. Chandra, should I uninstall and install 10.4?
No.
More than
yeah. If you want, you can install it. But for the learning purpose, 10.2, 10.4 is everything same only.
Oh, okay, fine.
Okay. There is no differences.
Okay.
If you have already installed, leave it. But if you are thinking that, okay, I can go for one more higher version. Okay, what is there? I have to check. Then you can go
for this itself system is slow, Chandra. So
I
think
go
leave
for
it that way.
Go for only 10.2. Okay, that's enough. More than enough. See, I'm going to use 10.2 only.
Okay.
So we are also working on 10.2 only in real time. So now we are January 2022. Our Informatica admin team is upgrading it 10.5 version. Next version. Okay, it's a more cloud integration we will do.
Okay, Chandra.
Okay, any other questions? Ramya, are you clear?
Yeah, kind of.
Okay, if you need any help on the installation, please let me know for all of you. Okay,
Sure.
You can install it, no issues. I think you are very new to SQL also. That's why your primary key, foreign key, and everything you will be getting little bit tough. But go to my SQL video. You go through it. Okay. So one session.
Sorry, the same thing, like as you mentioned, primary key and foreign keys are new to me. So
correct. So I understood. See, if you are very new to SQL and all, definitely that will be a little complex only by understanding. That's what I'm telling, that I have explained very clearly what is primary key, what is foreign key. So go with day-wise content. Okay, day 1, if you are clear, day 2, day 3, like this. I have explained what is schema. So what is database, what is DB link. Everything I have explained in the Oracle database. So please go with one by one database level. You make a note of it. You take a paper and pen and everything, note it, and then learn it. Okay. So install the Oracle first. For the Informatica installation, first we are installing Oracle, right? So this Oracle itself, you can practice for our SQL. See, whenever we are going for ETL developer role, so definitely you need to have knowledge on SQL. 50% of the knowledge will be used on SQL only. Okay, SQL only. That's what I'm asking repeatedly. So please go through that SQL. I will take one session on SQL, how to take it. And also sometimes I will conduct some SQL session. So anybody needed, I will include it. So 1 or 2 sessions I will, I will take it. Okay. Like joins or some other SQL session, I will take it. That time I will include.
Okay, thank you. So basically, if I install the SQL Oracle 11G, so you have all the notes in your SQL, videos where I can able to practice.
No. Yeah, the SQL notes I have sent it to you yesterday. That notes I have sent yesterday on SQL session I have sent it to you, right? So
yes,
in that we are in that we have attached, in that mail itself I have attached day 1, day 2, day 3. I have sent it. So everybody I have sent yesterday.
Okay, thank you.
Okay, anybody, if you didn't get it, please let me know. I will send it. Okay.
In
SQL
that English
notes,
sessions, only 5 sessions is there. And
I
only
will
6
add it.
sessions.
Yeah, correct. I will add it one by one.
Okay.
So first we go through one by one. So each day I will add one by one. Okay. So I'm working on it. I will add it.
Okay.
Chandra, the homework that whatever you gave, right? Types of dimension and types of facts. It's just that you want to list out the dimensions and facts. That's all.
That's all. What is that? What is that dimension? Say, for an example, if you are saying that a type of dimension is conform dimension. So what is conform dimension? See, one single dimension table will be used in multiple fact tables. Okay, that's a conform dimension. That you have to check.
Okay, whatever you have explained, we have to just write it out. That's all, right? Okay, fine. Yeah, okay, fine.
No, not that one.
Oh,
See,
okay.
types of dimension is different. So I told, right, it's a conformed dimension. Conformed dimension I haven't explained, right? So conformed dimension, slowly changing dimension, degenerated dimension, that you have to list down, and you have to check where it will be used, how it will be used, how this is connected with each other. The data model I was showing on data model, PDW, right?
Yeah.
So how it will be, see, conformed dimension is nothing but dimension table only. If you say date dimension, it's a conformed dimension. What is that? So this dimension table will be used in multiple places, multiple fact table. That's what the conformed dimension. Just you can check it. Okay, what is it?
Okay. It's in the part of your video only, right, Chandra? That whatever you taught us, that is the thing, right?
Yes, correct.
Okay, fine.
But most perhaps you use only slowly changing dimensions. Only, right?
Yes, only slowly changing dimensions.
Okay, but for the knowing purpose, we need to know this.
Yeah, what is that? Why? Because the interviewer, they will ask questions. Okay,
Yeah, got it.
if you are saying that I have worked on 5 years, 6 years in Informatica or data warehousing environment. See, these terminologies you should know.
Yeah.
Okay.
They will ask questions.
Okay,
Got
Chandra, fine.
That's what I have taken 2-day session. Okay.
Yes, Chandra, sure.
So next day, tomorrow, I will give you overall idea about Informatica. What is Informatica, how the architecture and everything. Before going for the practical session, you should know the basic of Informatica. Yes. So what is source, what is target, how it will be moved data. So then only whenever some error is happening, you can able to identify where the troubleshooting, all this you can able to understand. Okay.
Sure, Chandra.
Will
Yeah.
you share this? Will you share the video of today's class?
Yeah. At the end of the day, I will share all the videos. Okay. End of the day, I will share.
Okay, thank you.
So each day I will share. After it will take some 1 hour to convert. So after that, we will share. I will share. Okay. Yes, Vignesh. Yeah, you have to check the different types in Google. You have to make a document. That's all. Just for
But
your
Chandra,
reference.
mostly in SED types is very, very important. So even in
SAD,
Snowflake, SED type is an important thing. Actually,
yes, correct.
I mean, the
So you are using
documentation.
Snowflake as the data lake.
Yeah, correct.
Okay. So Snowflake, what is underlying data lake you are using? So we have something like GCP. We have something like
AWS S3.
Okay.
Yeah.
You are using AWS S3, right?
Yeah, correct.
Informatica also you are using.
Okay.
Yeah,
we have third-party tool. Actually, there we can do very, very easy access. Actually, we can just import third-party tool and then we can just straight away start working on it. But
okay.
That is for Snowflake, but here it is completely different.
Yeah, that's what. See here, if you know this ETL process clearly, then Snowflake or GCP pipeline or this cloud pipeline, right? It's very, very easy. See, I
very easy.
Yeah, I haven't learned any GCP pipeline and all. So after Informatica, they have moved me into a GCP, right? So just we have done some internal training, and then so we were taking up
there is one concept is there. Actually, Snowpipe one concept is there.
Yes, correct.
That's where the data, ETL flow, which will be coming in Snowflake. Actually, there they're using all these SQL types, SQL queries. Everything is same. Only thing is, that the data modeling is different, like processing and data storage is different.
That's why
and rest
I'm
of them
telling
same,
repeatedly for my students. So learn SQL very clearly. This SQL will be coming to you all over our career. Okay. SQL is very, very important. See, BigQuery SQL is different than this our Oracle SQL, but 90% is same. 90%
the concept
of the
is
queries
same.
are
Concept is same.
Yes. Slight 10% of the query will be different. That's all. But joins and everything is same.
Yeah.
Chandra, you will be taking the joins, that class SQL somewhere anytime near soon, Chandra?
Yesterday only I have, not yesterday, last week I have taken and then I have posted into YouTube. So if you have time, so please go through that YouTube. I have Tamil, both Tamil and English. You can go through it.
Okay,
so
Chandra,
I have given clearly like 1 hour session. You
I'll
can
watch
watch
that.
it.
If I have anything, I'll ask you.
Yeah,
fine.
if you have any questions on SQL, that's what the difference between YouTube session and our live session. If you have any questions on our training program, you can ask me. Okay,
Okay,
I will help
fine.
you out. And also, if you are facing any issues on the installation or issues on the day-to-day exercises, you can share your screen here. You can ask. So we will have question and answer like last half an hour session. Okay, last half an hour or last 20 minutes we'll have it. Why? Because it will not impact on the first 45 minute session. Okay, we will have all your questions. So yesterday's questions. Okay, I'm asking yesterday's doubt, yesterday's questions. We will have to say last.
Okay, Chandra. Fine.
Why? Because
Okay.
in between, if you are asking yesterday's session question, right, it will impact. See the flow, it will impact. That's why. So you can ask me any doubt. So we will have it like a separate QA at the end of our session. Like we will have last half an hour, 45 to 115, that we will keep it. See, whatever you have, that's what the difference between our Udemy course or YouTube course. Okay, YouTube. So everything is not there and you will not go for systematically. But here we will have systematically. Okay. And if you have any questions, you can ask me related to project also.
Okay, Chandra. Sure.
Yeah. Thank you all. So we will meet again tomorrow, same time.
Thank you.
Okay, Chandra. Bye.
So we will complete tomorrow the ETL concept, Informatica installation. I will tell you the weekend, Saturday, Sunday, you can install it, keep it ready. If you need any help on installation, we will sit on the weekend. I will take your machine remotely. We will complete. We will ready set up by this Sunday. Okay. From Monday, we will have Informatica hands-on.
Okay.
Okay, Chandra.
That's what the program. Okay.
Okay,
Okay,
Chandra. Yeah.
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 Thank you all. Thank you very much.
Thank you.
Any questions?
No. Please create WhatsApp group.
Yeah, I will create today. Yeah.
Okay.
Thank you.
Yeah.
Thanks.
Thank you
Thanks,
all.
Chandra.
Thank you.
Thank you, sir. Thank you all.
Thank you all.